Hello, welcome to the Muddiest point follow-up for hydraulics, class 6, hydrostatics 2. So let's start with the basics. This is a non-pressurized system, and we have a couple of factors that we look at. We have the centroid, and we have the center of pressure. And let's review the definitions associated with those, because those are important for a lot of the calculations that you'll do. We have L sub C and L sub P, and that's the distance along the inclined plane to both the centroid and the center of pressure. So L sub C is the distance to the centroid, and L sub P is the distance to the center of pressure. We also have the other set of variables, which is H sub C and H sub P. H sub C is the distance, the vertical distance from the water surface to the centroid of the object that we're looking at, the submerged object. H sub P is the distance to the center of pressure from the water surface vertically. And that location of the center of pressure is representative of the location where the resultant force acts. And you would use this location if you were summing the moments to figure out how much tension perhaps is required in a pulley to open a gate. So just to review, we calculate the resultant force as the specific weight times the distance, the vertical distance to the centroid, times the cross-section area of the object that we're looking at. And then that center of pressure, that L sub P or H sub P value, is calculated as L sub C, the distance to the centroid along the plane, plus I sub C, which is the centroidal moment of inertia, divided by L sub C times A. And this location is something that is especially confusing when we talk about piezometric head. So let's move on to that because that's the biggest piece that I know that you've been thinking about. So we have this example here, and we have a tank with oil in it, and it's pressurized, just like the example problem we worked in class on Wednesday. And what we need to do is we need to convert that pressure to an equivalent head. A piezometric head is the term that we use for that. And we can calculate that piezometric head, or HA, as by dividing the pressure, so that in this case 1.5 psi, divided by the specific weight of water. And we can convert that to a head in terms of elevation. And so if we look at this schematic, here we have the representation of that artificial HA put on the same tank. So all of this up here, this top piece from this line above, is pretend, it's imaginary. And so that's the piezometric head that's added due to the pressure within the system. And so we've converted that 1.5 psi to that equivalent piezometric head that's imaginary, but it's very important because it affects the resultant force that acts on the object, the gate or the window that we're looking at. And it also affects the location of the center of pressure. So let's talk about all of the definitions that are associated with these variables. There's quite a few, and I've added some text to this slide to explain some of these. So we already know that HA is equal to PA, and as a reminder, that PA is the equivalent pressure that's added. And so that HA, so that's the PA divided by the specific weight, the HA and the LA are the equivalent depths of fluid. So that takes into account that artificial piezometric head, that pretend head that we've added to the system. And you can see here that HA right here and LA are the equivalent depths of the fluid from the pressure. So again, H represents the vertical distance and L represents the distance along the inclined plane. And then the next thing that we do is we compute the equivalent depth to the centroid. So still, this is the centroid of the face, the object, the submerged object, the window or the gate that we're looking at. And we compute that equivalent depth to the centroid by adding the depth to the centroid, excuse me, the actual depth to the centroid. We add that value to the equivalent depth of the fluid. So we add HC, which is right here. So this is the actual real surface right here. If we think back to this diagram here, this is the actual surface here, HC. And now here we have this pretend piece that we've added on top. And we have this HA, that equivalent depth of fluid. So to get the distance, the equivalent depth to the centroid, we add HC to HA. We can also calculate LCE, so that's the equivalent depth to the centroid along the inclined plane, but the value that we need to compute the resultant force is the HCE value. So talking about the resultant force, so for this system that's pressurized, we have the resultant force is equal to the specific weight times HCE, the equivalent depth of the fluid from that's along the vertical from the piezometric head surface, times the cross-section area of the object, the submerged object that we're looking at. And then the other piece is that we need to look at the equivalent depth to the center of pressure. So I think a lot of confusion came in with the example problem. Well, what are we looking at here? And so I've got it laid out. We have that the LPE, so the equivalent depth to the center of pressure, this is along the inclined plane. LPE is shown here, and we calculate that as the distance to the equivalent depth to the centroid. So we have LCE shown here, and we have LCE is calculated as L sub C plus L sub A. And then we use, again, the centroidal moment of inertia, and then that LCE value again, and the cross-section area of the face of the object, the window or the gate that we're looking at. So hopefully that clears up some of your questions about all of the pesky definitions.